Hey, PSTAT students, Mr. Mitchell here. I'm going to take a look at exploring data today. Go ahead and share my screen with you. So statistics is the science of data. We're going to interpret, organize. Really, there's four things about data. You have to be able to collect it. You have to be able to organize it. You have to be able to analyze it, and then you have to be able to interpret it. Really, that's the four pieces of statistics. So when we talk about individuals, that's usually people. Subjects could be another term that we use there. But we're going to have variables that we're going to be looking at. And we've already analyzed how we collect data, so some of that is going to be a little review. We have our individuals, but it could be animals or things. Typically, we talk about individuals. We're talking about subjects, that'd be people. Variables, any characteristic that we're talking about. If we're talking about people, could be height, weight. We're talking about cars, could be miles per gallon, or towing capacity, or something referring to that. We have our categorical variables. And again, some of this is review. That's where you're talking about something that's a category, something that's qualitative, something that you don't necessarily do calculations with. Some of the graphs that we will use are bar graphs or pie charts. Quantitative, got numerical values, so your height and your weight would be examples, salary, other things like that. So looking at some of these variables here, we're talking about there's 10 randomly selected U.S. residents from a recent census. So your categorical variables would be the state, your gender, your marital status. Your quantitative would be the number of family members, their age, your total income, and their travel time to work. Those would be your quantitative variables. So we will do different calculations. We'll do different graphs depending on whether we have quantitative or categorical. Okay. So we answered some of these questions on the previous slide. So I'm going to go ahead and copy those in there. That is fine too. Who are the individuals? It's the people, the 10 individuals that were selected. And then you have your categorical and your quantitative variables. Describe the individual in the first row. So that would be the person from Kentucky that has 2 family members, is 61, is a female, is married, total income is $21,000, and travels 20 minutes to work. That would be the individual. So distribution of categorical variables. The distribution of the variable describes what the value the variable takes and how often it takes them. Labels are used for categorical variables like male and female. So another would be the state. We talk about that as well when we're describing. The distribution of categorical variables lists the categories and gives either the count or the percent of the individuals who fall within a category. Another way of thinking about it, you can't do calculations with Kentucky minus Florida or Wisconsin plus Michigan. Like, that doesn't even make any sense. So when we talk about categorical variables, we're either going to have counts of them. So if I look at marital status, we have what, 2, 4, 6, 7 people that are married. Okay, you could say 7. Is 7 a lot or is 7 a little? Well, it depends on out of how many total. So 7 out of 10, that's a lot, or 70% or 0.7. So when we look at what it's describing here, we're going to either talk about it as a count. It was 7 out of 10 for marital status, or I'm sorry, it was 7, or we talk about it as a percent, it's 70%. So again, with quantitative, you can do direct calculations with the numbers, the actual data points. With categorical, you either have to talk about the counts or the percentages. So some of the graphs that we'll look at are the bar graphs and the pie charts. So we really won't make these graphs on our own very much. Typically, we are looking at these graphs or using technology. There's a few graphs from AP that we need to be able to make. A pie chart or a bar graph is not one of them. So they are good representations that we do with categorical variables. So pie chart, you're going to make slices. The percentages tell you how big they should be. When constructing, you take your percentage times 360, and that tells you how many degrees. And then, 180 is half the circle. The whole circle is 360, and 90 is a quarter of the circle. And you kind of go through there and construct it that way. So bar graphs, each bar is representing a category. Heights of the bars either represent the counts or the percents. There's a little more flexibility with bar graphs. Do not confuse a bar graph with a histogram, though. If I go back to my example of the bar graphs, here's my percent on my y-axis. My x-axis is my category. So that's how they're represented. Notice the bars are not touching in a bar graph because to make them, when you connect in a histogram, which we'll get to later, there's flow. There is no flow from one category to another, so they should be separated in a bar graph. Okay. So we want to stay away from bars that have pictures. This is very misleading. Obviously, this would be a good graph for a Macintosh, but very misleading graph. We would want to stay away from something like that. All right. So we're going to talk about two-way tables and marginal distribution. So here's a table where you have gender versus you're going to be rich. So the chances of getting rich are this way, and here's your gender. Here's your total. There's 4,820 people that are in this two-way table. It's a two-way table because you have rows with data and columns with data. So and they're both categorical. So that's when we talk about two-way tables, we're talking about categorical variables. And then you have your gender and your opinion going one way. The last row and column contain the total. The distributions of opinion and gender alone are called marginal distributions. Okay. And so that's what a marginal distribution is. So we often write them as percents. Usually percents are more informative than counts because you don't know whether, like I said, is 7 a lot or is 7 a little. Well, in that example we did before, 7 was a lot. 7 out of 10 was a lot. So we typically want to make these as percents. So we're going to take almost no chance. We find our number that was 149. So if I go back to my table, 149 was everybody that said almost no chance. So it's 194. Is that a lot or is that a little? Well, with this marginal distribution, almost no chance is very little. It's only 4%. So 194 out of 4,826 is 4%. So that's the marginal distribution of almost no chance. And then some chance, 50-50, good chance, and almost certain. You're taking the row totals and dividing by the total. It's a way that I look at it. If you needed to do a marginal distribution of gender, you would take these numbers, the column totals, and divide by the total too. So next we have a conditional distribution. It means there's a condition. You have certain conditions that not everybody else would necessarily have. So marginal distribution tell us nothing about the relationship between the two variables. It just kind of gives you a total. Conditional distribution describe a little bit more. So instead of almost no chance among women or almost no chance among men. So that we're specifically talking about the male and the female difference here. So instead of dividing by the total of 4,826, so let me go back to my graph. So we're ignoring this total, and now we're focused on the gender here that we have in this data collection. So these are our bottom numbers that we're going to be using because that's our condition. Our condition is women, condition is men. So we take all the women that said almost no chance and we put that over all the women. And same thing with some chance, 50-50, good chance, and almost certain. To calculate the men, let's see if I can get my pen to work here. Almost no chance for men. There were 98 men, and there's 2,459 men total. So for all of these, your bottom number is going to be the 2,459 because you're just simply looking at men here in this scenario. So I can go down right now without even thinking about anything else and putting all of these over 2,459. And then all I have to do is calculate my tops. So how many men were some chance? That was the 286 number over the 2,459. The 50-50 is the 720. Good chance was what, 758. And then almost certain was 5. Ooh, that's a bad looking 5. There we go. Now we fixed it. 597. And so you could calculate all of these in the decimals. Again, it would depend on whether you wanted to have it as a percent. We should do that. So this one, I'm going to write it over here. So I'm a little bit out of space there. This one was about 4%. This one's about 11.6%. This was 29.3%. This was 30.8. And this one's 24.3. All you would do is divide these in the calculator and then multiply by 100 to get those. And that would be your conditional distributions, if you will. And so at that point, you can try to make some comparisons. So here you can compare the females that said almost certain to the males. So you can start to draw some conclusions that maybe males think that they are more certain to become rich. And maybe there's reasons for that. And maybe we can go into some more analyzation of that. Okay. So here's another example of men's and women's opinions to get an idea. Here's a side-by-side bar graph. So we're still comparing the same concept, but we're going to look at it from a graphical perspective to see, is there a difference? It looks like almost none. Female and male are pretty similar. 50-50 about the same. When you get to some chance and then good chance, almost certain, it looks like males have a higher percent in their own minds of that they'll make more money. And then there's some females that think there's some chance. So that's kind of the discrepancy, whereas this group and this group are very similar. So again, just trying to analyze some of those graphs to learn anything from it. So we could also do a segmented bar graph. This is one of the graphs where AP has asked you to do before. So basically what you want to do, you're going to have one of your variables on the x-axis, and then the other thing will be the different colors will be the other variable. So here we're going to have male and female, and that was the condition. The condition is going to go on the x-axis. So the condition was the gender. So we put female here and male here, and then we look at the percentages that we got on our example here, our percentages, and we put them on our graph. So we put our female percentages, and we can color code them, or you could just make them look a little different, like draw some lines this way and draw some lines this way. Make it look different if you don't have colored pencils. But it should add to 100% because 100% of the females participated, 100% of the males participated, even if they're not exactly the same. So this is a segmented bar graph. It's more concise. You can just look at the male and female and compare them. Okay. It's one of those things where some graphs are better than others depending on the situation. Sometimes it's more of a preference. Association, we're trying to see if there is association between the two variables. Knowing one thing about one variable may help you predict something about another variable. Okay, so no, the men rated their chances higher at becoming rich. So that's something that we would want to consider moving forward. An association between gender and opinion on future wealth. Knowing that a young adult is male helps us predict his opinion. What would the graph look like if there was no association? Basically, there wouldn't be any difference about anything. But knowing that a male thinks that there's a higher chance of becoming rich. So if there was no association, there would be no difference. Okay. So go ahead and try the check your understanding and see how you do.